And the sad thing is that you wouldn't even know that you were wrong on the problem. All right, really quick. We had our problems. Everything else was fine. Our numbers were correct. We had 2 and 7. We had 5 and 11, correct? All of that is where we're at as far as getting the stuff, the information that was given to us. We're going to Desmo. Do we want to use Desmos? No. Yes, we're going to use Desmos. So we're going to just go ahead and talk about the regression models and following it. I think Desmos updated where you can do 2 points. If Desmos still doesn't allow us to do 2 points, then we're going to have to use the 84 because 84 does allow 2 points. All right, so here are our points. Just like before in Desmos, you would make the table, and I want you to be able to see the difference in what's right and what's wrong. 5 and 11. Yes, it does it now. Okay, so here are your 2 points. In the past, this little guy wouldn't pop up with just 2 points, but it does now, so that's great. We would click this button, and we would go to exponential. You see the difference in the B? Yeah, that's the difference in the B. That's the correct B. I click this guy, and it's going to write it for me. And now I have my function, my model, and this is what we should have gotten. As you can see, our numbers aren't that drastically different. Does that make sense? Like, that's what I'm saying. It's like wrong, but like, oh, kind of work math, but it was wrong. Okay. So our numbers aren't that drastically different, but they were wrong. So therefore, we're correcting it. Okay. So now that we have our exponential model here, this is what it should have been. This is what you're going to write. This is your exponential model. Okay. You can zoom out and you can see the curve of it. If we click here, I'm going to just show you really quick. If I went to linear, you would see that 4/3 that I told you we found in the beginning. It's right there. That's the thing that triggered me. So yes, so here's our model, and that's the answer. And then once you have it, you can calculate anything. And it asks us for 20 days, right? So after 20 days of the rumor spreading, could I find it? Yes, you have 2 options here. Option number 1 is you can click the little button here, the gear, and open the table, and you can type in 20, and it'll give you the answer. Okay. Option number 2 is you can always change it from y to f of x. And when you change it to f of x, that means you can tell the calculator whatever you want it to find. Okay. So either one of those work. All right. Okay. So the table part, the plus sign, what we've been pulling the table at, same thing. Oh, this table. Oh, yes. To grab the table, when you're here, you click the gear and the gear will pop up your table. Yep. And then you can type it in. All right. Okay. So we've learned by hand, we've learned by technology. Which one you choose is 100% up to you. Okay. Does anyone need to see it with TI-84 or you're sticking to Desmos? Again, I don't mind. It's not that bad. TI-84. Nobody at all? Okay, that's cool. All right, so what I want you to do is now that you have the tools, you're going to decide for the next practice problem, which way do you want to do it? Obviously, you're going to probably choose making your table and using Desmos, which is A-okay. So here you have the 1979 richest 1% of people in the U.S. own 23% of the nation's wealth. By 2019, the richest 1% of the people in the United States own 35% of the nation's wealth. Determine an exponential model for this scenario and use it to estimate the percent of the nation's wealth that the richest 1% people in the U.S. own in 1995. Okay, so this one involves years, correct? So when we are using years, we don't want to put the years into the calculator. Okay, so before I let you go, we're gonna create a table of information and we're gonna talk about putting years in. Okay, so here we're at 1979, and in 1979, how many people was it? 23%. They own 23% of the population, correct? And 2019, they own how much? 35% of the nation's wealth, not population, nation's wealth. So with that information, we're going to change our values. We're going to let 1979 be our 0. Does that make sense? And then how many years later is 2019? 40. So this is our 0. And then this is going to be 40. So when you're putting in your information, you're using 0 and 40, not the years. Does that make sense? Okay, that's because those numbers are too large. And if I'm using exponential models, remember, exponential is rapid growth, right? And if I'm already in the thousands and I'm rapidly growing, what's going to happen? It's going to get huge, and the calculator computer is going to explode. No, it's not going to explode, but essentially it's going to be lost. So it wants us to find, though, 1995. So 1995 would be what value that I'm looking for? If someone was born in 1979, how old would they be in 1995? There you go. Does that make sense? Okay. All right. I'm going to stop talking. I'm going to give you 3 minutes. Is that fair? You're going to find the model and find what would be the population percent in 1995. If you need my help, I will be walking around to assist. It's okay. We're good. We're going to keep rolling. All right. Let's keep rolling. Okay. Test it out again. Let's see. And go. All right, so let's talk about this one from the beginning. So I'm going to reset so I can make a new table, right? So my table values from the problem are what she knows for sure, right? I know for sure on day 0, I had how many in my dish? 1,000. I know for sure on day 4, I had how many? 2,000. The rest is her prediction, right? She's predicting for day 6 and predicting for day 8. And our job is to figure out, is her prediction correct? Okay, so I'm going to adjust my window to see it. I'm going to change my model to an exponential. And here is my rule that I got, right? Yes? Okay, so we got our rule. Once I have my rule, I just keep making it easier and easier for y'all to be great out here, I tell you. I can literally copy it down to the bar. Once I'm here, I open my table and I can see, is she right or is she wrong? So I'm going to type in day 6 and I'm going to type in day 8. Yeah. To open the table, once you've copied your equation down, you're going to press the gear and then you'll get your table option. And now I can change the values to fit whatever information I need. Okay. All right. On day 6, was she right? No, she was close, but was she correct? No. However, on day 8, she was correct. Do we see that? Yes. All right. Do we feel like experts? Huh? You feel like you're okay? You can move on to calculus? Okay. All right. So let's talk about your assignment that goes along with this. So you should have picked up the assignment when you came in. Did everyone pick up the assignment when you came in? Yes. Okay. So when you came in, you should have picked up, it looks like this. Okay. So instead of just 2 values, what do you have now? A lot. You have multiple values, right? So your table is going to get bigger. But is the process changing? No, our process isn't changing. Okay. When we have years, what do we say we're going to do? Turn them into numbers smaller than what they are, right? But we have to keep them spaced the same apart. Does that make sense? Okay. So for our assignment, let me see if I can open it on my end. So on your assignment, I'm going to pull it up here. So for your class, ignore the ed puzzle because I'm your ed puzzle. Like we just did it. Does that make sense? Yeah. I wasn't here for them. Okay. I'm your ed puzzle. All right, but here's your assignment. Okay. So here's our assignment. So just making sure we're all on the same page of what my numbers should be. For this first problem, what should my x's be? Okay, what is my x's I'm putting into my calculator to be? I start at 0. Do we put the years in the regression model? No. Okay, so we're starting at 0 and then we go. We get it? Okay. All right, let's go to the next one. This one, again, we're starting where? At 0, but how far apart are the years matter, right? It is not consecutive, so I can't just write 0, 1, 2, 3, 4. Does that make sense? I have to actually write 0 and then how many years later from each one of these points. Okay, so like here, I'm at 0, and how many years later is 1991? 4. How many years later is 1995? 4. No, it's not. 8. 8. It's 8 years later, right? Does that make sense? How many years later is what those values are going to be. So keep that in mind when you are doing it, okay? So just to make sure that we all understand and we're all on the same page. This is 0, right? This is 4. This would be 8 because it's how many years from my 0. Yes? And then we keep that going. Okay? Do not put the years in the calculator. I repeat again. All right? Okay? All right, so you're going to go through, create your scatter plot, find your model, your exponential model, and then you're going to answer the questions that follow. Is that a doable assignment? Homework assignment? Yes? All right, perfect.